Let's now discuss how we go about calculating the determinant of a 3x3 system. And to do so, we'll review two different methods. So we'll take a look at those methods separately. A 2x2 system has two equations with two unknown variables. For 3x3s, we have three equations, A, B, and C, that have three variables, x, y, and z. So the matrix that we'll be working with to calculate the determinants are 3x3. The first column represents the coefficients of our x terms, 1, -1, and 2. The second column represents the coefficients of our y terms, +1, -2, and +2. And the third column is represented by the coefficients of these z terms, +1, +2, and -1. So the 3x3s we'll be working with represent the coefficients of our three variables. Well, let's now walk through an example together to take a look at method number 1. So find the determinant of this 3x3. Column 1 is 1, -1, and 2. Column 2 is 1, -2, and 2. And column 3 is 1, 2, -1. Now, calculating the determinant of a 3x3 is slightly different than calculating a 2x2. We'll still be multiplying the numbers going down to the right and up to the right. But before we do that, the first step is to rewrite the first two columns to the right of the matrix. So we take column number 1 and column number 2, and we rewrite both to the right of the 3x3. So on the outside of our vertical line. So now we have a total of 5 columns, 1, 2, 3, 4, 5. We still have 3 rows, 1, 2, and 3. But now with this new setup, we can now multiply the numbers going down to the right, starting with row 1, column 1, row 1, column 2, and row 1, column 3. So when we multiply going down to the right, starting with row 1, column 1, we multiply +1 times -2 times -1. And what we're going to do is we're going to add the products from this step. So we multiply these numbers, put a positive in front of it. Since it's positive, we can just leave it as is. And now we'll go to R1C2. So still the first row, the next column over. And again, we want to multiply the numbers going down to the right. And we want to add this product. So we'll place a positive sign. And then we'll multiply 1 times 2 times 2. And then we repeat this process one more time, starting at R1C3. So we stay in the first row, but now we move over to the third column. And again, we multiply going down to the right. So each time we're going down to the right, we go down one row and over one column. This time we have 1 times -1 times 2. And for all three of these, they're all preceded with a positive sign. So those are step 2 and step 3. Now, step 4 and step 5, we first want to multiply the numbers going up to the right, starting with row 3, column 1, row 3, column 2, and row 3, column 3. So this time we're moving up, and this time we're starting, instead of with row 1, we're starting with row 3. And now when we multiply these numbers, instead of adding these products, we're going to subtract them. So we'll place a negative or minus sign in front of each product. So starting with row 3, column 1, row 1, row 2, row 3. Column 1 is furthest to the left, so we're starting with +2. And now we multiply the numbers going up to the right. So that gives us 2 times -2 times 1 here. And we place a minus sign in front of it since we are subtracting the products that we get when we're going up. So now we multiply the numbers starting with R3, C2, which would be +2 here, And when we multiply going up to the right, go up one row, go over one column for each one. We get 2 times 2 times 1. And we place a minus or negative sign in front of it. And now we multiply the numbers going up to the right, starting with row 3, column 3. So the third row, third column, so that would be -1. Going up to the right means we're multiplying -1 times -1 times 1. And we want to place a minus sign in front of it. So now, step 6, we can solve for D by evaluating this expression. So let's move the matrix to the side for a moment and evaluate each piece. So first we have 1 times -2 times -1, which would be equal to -2 times -1, which is +2. Then we add that to 1 times 2, which is 2, times 2, which would be 4. And then we add that to the product of 1 times -1, which is -1. -1 times 2 is -2. And then we have minus 2 times -2 times 1. -1 times 2 is -2. -2 times -2 is +4. And +4 times 1 is +4. Then we have minus 2, which would be -2, times 2, which is -4, times 1, which is -4, minus -1. -1 times -1 is +1. +1 times -1 is -1. And -1 times +1 is -1. So D will be equal to 2 plus 4, which is 6. 6 minus 2 is 4. 4 plus 4 is 8. 8 minus 4 is 4. And 4 minus 1 is equal to 3. So the determinant of the system is equal to 3. So that is how we go about finding the determinant of a 3x3 system using method number 1. Let's now have you try a few practice questions. Question number 1, find the determinant of this 3x3. Column 1 is 1, -2, +2. Column 2 is -1, +1, +3. And the third column is 2, -1, -2. Question number 2, column 1 is 1, -1, and +3. The second column is -1, 2, -3. And the third column is -1, -2, and +1. Pause the video, answer these questions, and then press play when you are ready to begin. Question number 1, step 1, rewrite the first 2 columns to the right of the matrix. So we take columns 1 and 2, and we rewrite both to the right of our third column. So we place them here. And now step 2, multiply the numbers going down to the right, starting with R1, C1. And then we want to add the products. So we have 1 times 1 times -2. It's positive in front. And now we go to R1, C2. So that would be first row, second column, -1. And we multiply the numbers going down to the right, giving us -1 times -1 times 2. And we're going to place a positive sign in front of that product. And now we go to R1, C3. So the first row, third column is +2 here. And we multiply the numbers going down to the right, giving us 2 times -2 times 3. And we're going to place a positive sign in front of it. So those are steps 2 and 3. Step 4, multiply the numbers going up to the right, starting with R3C1. So that would be the third row, first column, which is positive 2. And then we're going to subtract the products from this step. So if we're multiplying going up to the right, we have 2 times 1 times 2. And we're going to place a minus sign in front of it since we are subtracting these products. And now we go to R3C2, third row, second column, so that's positive 3 here. And we want to multiply the numbers going up to the right, which should be 3 times negative 1 times 1. And we'll place a minus sign in front of it since we're subtracting it. And now, starting with R3C3, third row, third column, is negative 2 here. And we multiply the numbers going up to the right, which would be negative 2 times negative 2 times negative 1. And we'll place a minus sign in front of that product. So now step 6, we can solve for D by evaluating this expression. So let's put the matrix to the side. And we see D is equal to 1 times 1, which is 1. 1 times negative 2 is negative 2. Plus negative 1 times negative 1, which is positive 1. Positive 1 times 2 is positive 2. Plus 2 times negative 2, which is negative 4. Negative 4 times 3 is negative 12. Minus 2 times 1, which would be negative 2 times 1, which is negative 2. Negative 2 times 2 is negative 4. Minus 3, which would be negative 3, times negative 1, which would be negative 3 times negative 1, which is positive 3. And positive 3 times positive 1 is positive 3. Negative 1 times negative 2 is positive 2. Positive 2 times negative 2 is negative 4. And negative 4 times negative 1 is positive 4. So we see D is equal to negative 2 plus 2, which would be 0. 0 minus 12 is negative 12. Negative 12 minus 4 is negative 16. Negative 16 plus 3 is negative 13. And negative 13 plus 4 is negative 9. So the answer to question number 1 is D is equal to negative 9. So that is the answer to question number 1. Let's now have a look at question number 2. Step 1, rewrite the first 2 columns to the right of the matrix. So we have column 1 and column 2, and we want to rewrite both of these here to the right of the matrix that we were given. And now, step 2, multiply the numbers going down to the right, starting with R1, C1, which would be positive 1 here. And step 3, add the products from step 2. So we'll place a positive sign in front of each one, giving us 1 times 2 times 1, plus negative 1 times negative 2 times 3, plus negative 1 times negative 1 times negative 3. So those are steps 2 and 3. So now step 4, multiply the numbers going up to the right, starting with R3C1, R3C2, and R3C3. And then step 5, subtract the products from step 4. So we'll place a minus sign in front of each of these products, giving us minus 3 times 2 times negative 1, minus negative 3 times negative 2 times 1, minus 1 times negative 1 times negative 1. And now, step 6, we can solve for D by evaluating this expression. So let's move our matrix to the side. And we see D is equal to 1 times 2, which is 2. 2 times 1 is 2. Plus negative 1 times negative 2 is positive 2. Positive 2 times 3 is positive 6. Plus negative 1 times negative 1 is positive 1. Positive 1 times negative 3 is negative 3. Minus 3, so that's negative 1 times 3, which is negative 3. Times 2 would give us negative 6. And negative 6 times negative 1 is positive 6. Then we have negative 1 times negative 3 is positive 3. Positive 3 times negative 2 is negative 6. And negative 6 times positive 1 is negative 6. And negative 1 times 1 is negative 1. Negative 1 times negative 1 is positive 1. And positive 1 times negative 1 is negative 1. So we get D is equal to 2 plus 6, which is 8, minus 3 would be 5. 5 plus 6 is 11. 11 minus 6 is 5. And 5 minus 1 would be 4. So the answer to question number 2 is D is equal to 4.